Okay, another discussion board question. Hannah, we have the scores on the test have a mean of 71 and a standard deviation of 14. Does that make you think of any kind of picture we could draw?
The bell curve.
The bell curve. Here we go. You like my lovely bell curve? All right, it's not
Yeah.
symmetric. They never are when I draw them quickly. Oh well. Okay, so um, what do we put on the bell curve? You can either put it in or I can. What things do we put in the bell curve?
The center line is
This
the
the center.
mean, right?
Okay, the center line is the mean. And since it's a normal curve, it's the mean, median, and mode. But yes, so what number goes there?
71.
71. Good. And that's the mean, the median, and the mode, which I'm trying to write, and we'll see if it works. Median and mode, because it's a normal. Does it say it has a, oh, it doesn't say it's a normal curve, but I'm going to assume that it is because it's asking for z-score. We'll get there. Okay, so mean, median, and mode. All right. And when you think of normal curve, what do you think of? What do you know about the mean and standard deviation normal curve thing? What do you remember before we even get to the question or anything?
So when you go to like the right of the bell curve, you like add 14 each time to get each um what are they called?
Okay, it's a standard deviation,
Standard
and you're right.
deviation.
We go over here and we would add 14, 71 plus 14, 71, 81, 85, right?
hmm
So you're thinking this, which is good. If you're thinking it, we're going to write it. And then 71 minus 14, you know I'm horrible at subtraction. What is that?
Oh my. It's 57.
Okay, 57. Trying to write 57. It's letting me. Okay, so 57. All right. And what do you know about, like, why did you do that? What do you know? Do you know something about those specific values?
Because in between 57 and 85, I know that it's 68%.
68%. Okay. So, like, most people on this test scored between a 57 and an 85. Okay. So, um, we're not going to have to do the entire normal curvy thingy thing here. So let's go ahead and go over to the question or talk about Tony. Um, so what do we know about Tony?
He has a score of 88.
Um, oh, and you're writing it on there. I can see it. Like, I don't know if you can see it on the recording yet, but I see you writing where 88 would be. So we've got the 88 um, going on there. So Tony did better or worse than most people in class.
He's better than most people.
Okay, so we need to figure out where that is. We know that 68% are between the 57 and the 85. And then the next values we know, the 43 and the 99. Now, it's asking us to convert Tony's score to a z-score. Hannah, do you remember, or did you read, or a lot of people don't remember this? What is a z-score?
I honestly don't remember.
Okay, awesome. But there's a lot of things you do, not awesome, sorry. There's a lot of things you do um, remember. So let's talk about the things you do remember. Um, how many standard deviations above the mean is, can you see that red mark? You can, is the 85?
How many?
How many
It's one.
standard, right, that's one. So this is plus, let me see if I can write, plus one standard deviations. What about this 57?
It's
What
minus one.
minus one, right? We're going to put a minus one standard deviation there. Okay. What about the 99? How many standard deviations above or below the mean is the 99?
That would be two.
Yep.
Plus
So
two.
this is a plus two. Okay. I'm trying to write this. And the 43 would be a, how many standard deviations away is that? I just lost your volume. Okay, so we had a little issue with the microphones there, but the 57 and 85 are plus and minus 2 standard deviation, or 1 standard deviation, and then the 43 and the 99 were the plus and minus 2 standard deviations, and that's the empirical rule stuff that we did in the previous section, which gives us 68, 95, and 95% of the data. Okay, so what I'm going to tell you is that the z-score is actually, and I'm going to try to write in yellow to not make too much of a mess, but it probably will be a hot mess. The z-score is actually the number of standard deviations away from the mean. So that you actually have identified z-scores without knowing that it was a z-score. So the z-score is literally just the number of standard deviations away from the mean, which is probably worth writing on here. So let me just do that. All right, we're just having this like written here. The z-score is just the number of standard deviations away from the mean. So there's a couple different ways to think of the z-score as the couple different number of standard deviations away from the mean. And there's a formula that is in your book that you may or may not have looked up. It's the end of the semester. We're all exhausted. Let's write it down. Okay, let's write the z-score formula and talk about what it means. The z-score is the number of standard deviations away from the mean. So it's your score, and we'll go ahead and highlight that in a minute. Your score, whatever you got, so Tony got his 88, minus the mean, so how far you are away from the mean, divided by how big the standard deviation is. So in this case, let's plug everything in. So the x is Tony's score, so let's do that just in black. So in this case, z equals, what is Tony's score?
88.
88 is Tony's score. What is the mean?
71.
Okay, so 88 minus 71. Come on, write a 1. There we go. Divided by, and what is the standard deviation?
14.
14. Awesome. Before we even calculate, okay, I want to come over here, and before we even calculate, right here is where Tony is, okay? You already know something about his z-score. Where is he roughly on the graph as far as the number of standard deviations away?
He's a little bit more than 1 standard deviation away.
Right. So we already know it's going to be 1 point something. It's between 1 and 2. Yeah. Okay. Awesome. So let's go ahead and see what we get by calculating this. So 88 minus 71. Can you do that?
Yeah.
I mean, we probably both can, but we're probably both like so fried.
17.
17, that totally makes sense. 17, okay. 17 divided by 14. So we already knew it's a little bit more than 1, and 17/14 certainly looks like a little bit more than 1. Most of you are going to just stick that in your calculator. I want to turn it to a mixed number first because I'm so like used to doing that, and you've seen me do that a million times, because 14/14 is 1, so it's really 1 and 3/14. Can you see that 3? Is that legible? Okay.
Yeah.
Which we're all going to stick it in our calculators anyway, so it doesn't even matter. Nobody's going to do that. So did you stick it in your calculator yet?
Yeah, it's 1.21.
Exactly?
No, I rounded it.
What'd you get first?
1.2142875.
Blah, 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 right? We're running out of space. Okay, so I'll just keep like saying just stuff over there. Okay, so, but you were good about reading the directions. The directions said round to the nearest hundredth. So you did. And you said then our answer is going to be, oops, that's not a pen. Our answer is going to be 1.21 because the 4 does not make you round up. Okay, which totally jives with what you said here. It's between the 1 and the 2, between the 1 and the 2, but it's closer to the 1, so 1, oh, no, it's not letting me write again. So 1.21 also feels right. So the z-score is literally just how many standard deviations away from the mean you are. It's positive when you're above the mean and negative when you're below the mean. And I guess I'm going to go ahead and try to highlight one more thing here so that you know, what should you do with this formula right here? Where should you write that formula?
In my notes.
In your notes, especially the notes you're going to have on the test. And you should also write this, what the z-score is, because you knew when I was talking to you what these were. You knew we were going up and down 1 standard deviation. You knew the empirical rule, but we're all getting tired and it's hard to remember anything. So hopefully this helps, and we'll make more videos. You keep asking questions, we'll keep making videos.